we're going to write down the important stuff that happened here to this equation. First of all, it's a parent function, which means it's based on some function we already know. Which function is that? X squared, which looks like a what? A parabola. So this is a parabola, and here's all the things that have been done to the parent normal parabola. This one has that. Okay, so everybody just go ahead and draw what I just did, an arrow to that first negative. Now that is a flip, but I'm trying to start you using the more official term for flip, and what's that? A reflection. It's a reflection, and I'm still going to stick with up-down reflection. And that does go over one of the axes, but you can think it through. If it goes up-down, it must be going over the x-axis, and you can think it out. Don't try to just memorize that. Memorize that it's up-down, because anything on the outside here or here is up-down stuff. All right, so that's a reflection over x. That number is either a stretch or shrink. In this case, what is it? It's a stretch. Okay, it's a stretch. And I'm going to say that it is stretch up-down, which is also known as, in the real world, vertically. So it's a vertical stretch. And in this case, it's a 2, which means it's twice as tall as it used to be. All right. Next, let's look at, see this one here. That part, that's a reflection again. But which way? A left-right reflection. Left-right reflection. Reflection over which axis? And you can do that by process of elimination. The other one was over the x, so this must be over the y. But I want you to think about it. If it goes left-right, think through, picture it in your head. If it's going left to right, it must be going over that y-axis. Okay. And then we're through the difficult stuff. Now we got the easy stuff. Remember that from when we learned it about 2 weeks ago? Left 3. Now if it had been negative 3, then it would have been what? Right 3. Remember, it's inside, so it's counterintuitive. Adding seems like it should move to the right, but instead it moves to the left. And the last thing is, oh, what color haven't I used a lot of? Let's see, red. That's going to be up 6. We can trust the stuff on the outside. It seems like positive is up, so it's up 6. All right, that's crucial to understand all of the transformations. It's been transformed from the parent to that, and it's a whole bunch of points on the test, for one thing. All right, next thing is, what if I asked you to graph this without a graphing calculator? No, it's not that hard. One of the things that would be crucial, though, is that you know where its vertex is. So let's look at vertexes for just a second. Remember the vertex for these guys? These are the parent functions. The vertex is that spot at the bottom. My alignment's off, so anyway, I think you know what I meant. And that spot over there, that's the vertex. And then this spot right here, that's the vertex. This place where it starts. Right? That vertex is crucial. So there's a way to recognize that vertex by just looking at the equation. And I want to teach you that next. So if I have y equals 2x plus 3 minus 5, I already know what the vertex is of that. The vertex is how far it always starts at 0, 0, right? And then it moves according to these guys. This is a multiply, and that doesn't change 0, 0. 0, 0, when I multiply it by something, stays at 0, 0. But this moves it, the green things here, this and this. So, what do you think the vertex is? Yes? Negative 3, negative 5. Now, he was smart enough to notice and remember that that wouldn't be a positive 3 because it's counterintuitive, and so it must be negative 3. So if I actually used a graphing calculator and graphed this, yes, the vertex would be at negative 3, negative 5. All right? That'll work also. This one was with an absolute value. Same exact thing works with a square root. 7 times square root of x plus 8 minus 9. What do you think the vertex would be here? Negative 8, negative 9. That's the vertex. All right. So back to this where I said it would be important to know how to graph that. All right. I've made a slide sort of ready to graph. And Where should I start again? At the vertex, which is negative 3, 6. So I'm going to start graphing there. Negative 3, positive 6 is right there. Okay? Now, I think the easiest way to show you that will always work is if I make you an XY chart like this. On your scratch paper, I'd like you to make an XY chart like this with me. And I know my first point is negative 3, 6. I know that's on my chart because that's the vertex. That's one of the key points. And now we're just going to find a few other points to graph. Need something to write with? I can lend you something if you need one. Oh, you've got something. Okay, I just couldn't see it. All right, get it out and use it. All right, this is the first point. Now we're going to find some more points. Heidi, what's something that's close to negative 3 that I could try plugging in next? Negative 2. If I stick in negative 2, it's an x, so I'm going to put it in right here. And now let's do this together. I'd like you to respond verbally. As soon as you can think of the answer, we're going to multiply it out together here. Negative 2 plus 3, what does that make? 1. What's opposite of 1, which is what? Negative 1. Negative 1 squared. 1 times negative 2. Negative 2. Negative 2 plus 6. 4. So that's one of my points. Negative 2 comma 4. All right, now let's plug in another one. This is not rocket science. Just find another one that's close by. How about negative 1? And I stick in negative 1. I put in negative 1 here. What's negative 1 plus 3? 2. 2, and the opposite of 2 is? Negative 2. Negative 2 squared is? 4. 4 times negative 2? Negative 8. Negative 8 plus 6? Negative 2. Yes. We're using negative 2 when we're multiplying that, so that's there. We're using it. This negative? Yes, I'm using that as well. When I'm multiplying, I'd say, okay, now take the opposite of it. That's what the negative is doing. So we'll do, just listen to me close as I go through the next one. I'm going to put in 0. Okay? So now I'm going to put in a 0 here. 0 plus 3 is? The opposite of 3 is negative 3. Negative 3 squared is? 9. 9 times negative 2. Negative 18 plus 6. Negative 12. Now, do you notice that my numbers are starting to get kind of big? Like when I graph that, that might go off the page. So what's happening is this is that parabola, and this parabolas are based on squaring something, which means your numbers are eventually going to get really big. So maybe I should start going the other direction. Instead of going from negative 3 down to negative 2, down to negative 1, down to 0, maybe I should start going the other way. And what should I try now? Negative 4 would be going the other way. See what I mean? So I'm going to try sticking in negative 4. Negative 4 goes in here now. It's getting kind of messy. Negative 4 plus 3 is? Negative 1. Negative 1, and take the opposite of that? 1. 1 squared is? 1 times negative 2. Negative 2 plus 6, 4, and I could have predicted that. Know why? This is the parabola, and there's going to be mirror points. See how that one goes with this one? And if you're smart enough, you'll be able to just go, oh, and so negative 5 is going to be another mirror point. So what do you think it'll be? I'm guessing, no, it can't be negative 6. That was the vertex, and the vertex is the only point that doesn't have a mirror to it, right? And so it won't be that one. Probably be negative 2, but let's just test it and make sure. If I stick in negative 5 here, negative 5 plus 3, negative 5 plus 3, negative 2, make that the opposite. 2 squared is 4 times negative 2, negative 8 plus 6, negative 2, and it worked. Cool. Okay, so at the end, you only have to stick all the numbers in because you'll start realizing, oh, that's a mirror, and you'll be able to just start copying them down. All right, if I graph all those points, I will have my parabola. So I just have to graph them. So I go negative 2, 4, negative 2, up 4, and negative 1, negative 2, negative 1, negative 2, goes down here, and 0, negative 12, 0, negative, whoa, it's off the screen. Next one's negative 4, 4, negative 4, 4, etc.